Uh, hello, Didintle. How are you?
I'm good. How are you, sir?
I'm good, thanks. Hey,
Okay, sir.
how's math going?
It's going just okay, sir. I'm
Nah,
writing math. Yes, sir. But I'm writing math this Friday, sir. So I'm.
is it paper one or paper two?
Sir, can you hear me?
Oh, yes, I can hear you. Can you hear me that side?
Yes, sir.
Okay, thank you. I was asking, like, are you writing paper one or paper two this Friday?
Paper one.
Oh, man, but I believe in you. You're gonna kill it, eh?
Thank you, sir.
So you want us today to work in Euclidean geometry? Which part?
Yes.
Let me
The sir.
let me quickly share my screen now. Can you see my screen that side?
Not yet, sir. Yes, sir.
You now can.
Yes, sir. So I was thinking maybe we could do maybe a past paper so I can see where I stand and I can send you a picture on WhatsApp after the lesson or during the lesson. However.
So I'm not sure if I understand what you are asking. You suggest that we do past paper.
Yes, that's focusing on like the questions that focus on Euclidean geometry.
Oh, okay. Let me see if I can find something for you here. Okay. Uh, but how is it going though with Euclidean geometry? Are you getting there?
Yes, sir. Yes, sir. I, I- I'm understanding, sir.
Oh, that's good. That's good. That's good. That's good then. I think I'm having this now. And then let me share again. Can you see my screen that side?
Yes, sir.
Okay. So I've got these problems here, then we can work on as many as we can. Is that
Okay, sir.
fine?
Yes, sir.
All right, all right, all right. We maybe can start on this one. So this question, I think, is the Western Cape one 2018. They are saying there, ABC is a semicircle with a center O. So AB is produced to K such that KCS is a tangent. Oh, this is an important information. This one. This is an important, and also this one. Okay, to the second. So OSSO here, this is also an important information. KCB is equal to 25 degrees. So with this grade 11 Euclidean geometry, I would always recommend this technique to anyone, DRCPT, Dr. Cape Town, whereby I always say this D is the diameter to the circle. If there exists a diameter to the circle, so this is our circle here, and then this is our diameter, then there will be those lines, those chords there. And then where those chords meet, they intersect perpendicularly there, they form that 90 degrees right there. Does this make sense to you?
Yes, sir.
Okay, fine. Then we are done with that diameter. Now let's go to the radius. Oh, when you define the radius, you know that the radius is the line from the center of the circle to the point on the circumference. It can be this one, it can be that one, it can be that one, it can be that one, the radius. But the radius is equal everywhere. So if maybe I join these two radius here, then this line is equal to that line. Both of them are radius. Therefore, this triangle of mine, let's say triangle OAB. Then this triangle now is an isosceles triangle because these two sides are equal. Therefore, this angle will be equal to this angle here. Reason being angles opposite equal sides. Does this part here make sense?
Yes, sir.
Okay, thank you. Then now, let's come to our back to our diagram. Using this radius information, maybe. Okay. Oh, see, it's a radius. We can see that. also an OB. It's a radius. Therefore, angle B1 here will be equal to angle C3 right there. Reason being angles opposite equal side because OB is equal to OC. Do you agree?
Yes, sir.
Okay, thank you. Same applies with O. Let me maybe use different color. OC here is equal to OA here. Therefore, this angle will be equal to that angle because of this radii here. Then I think we are done with this radius information. We can now move to the C. C is a cyclic quad. So with C, which is a cyclic quad, we need to know the properties of a cyclic quad now. Or okay, if this is our circle and there exists the cyclic quad in that circle of ours, you need to know the first property of a cyclic quad is that opposite angles of a cyclic quad are supplementary. What do we mean by supplementary? When you add them up, they give you 180 degrees. Same applies with this angle here. When you add it to this angle, you get 180 degrees. Reason being, opposite angles of a cyclic quad are supplementary. Then if now we extend this chord here, we're gonna say now this angle out here, this one here is going to be equal to that angle. Reason being exterior angle is equal to the interior opposite angle of a cyclic quad. Then the last property that you need to know of a cyclic quad is that angle, that bow tie shape that I love talking about. This one, that this angle is equal to this angle, reason being angles in the same segment. And again, this angle will be equal to that angle, reason being angles in the same segment. Then you are done with the cyclic quad. Then let's go have a look on our diagram, see if we can see something for the cyclic quad. Okay, for now, no. Okay, then you pass it. Then P, parallel lines. So you only apply, or I mean, you only use this technique. Maths is fun. This one, maths is fun only if there exist parallel lines. If there are no parallel lines, you can't come to this technique whereby you're going to say corresponding angles, co-interior angles, alternate angles, if there are no parallel lines. Does that make sense?
Yes, sir.
Okay, thank you. So there are no parallel lines here, so we can just pass that P. Then we go to T, which is the tangent. What do we know now about the tangent is that if there exists a circle and a tangent and the triangle in the circle that is in contact with that tangent, that now this angle between the tangent and the chord is equal to the angle in the triangle that is opposite the chord will be equal to that angle, reason being tan chord theorem. Same applies with this other one. This angle here will be equal to that angle, reason being tan chord theorem. So let's see if we can cook something for the tan chord theorem here. Okay, there's a tangent between the chord, or there's an angle between the tangent and the chord. So this angle will be equal to that angle. This angle will be 25 degrees. And we've said using our analysis, this angle is equal to that angle. This angle also will be 25 degrees. Okay. And then what else that we know about the tangent is that if this is the circle, this is the tangent, this is the center of the circle, this is the radius. Where that radius meets the tangent, they intersect at 90 degrees. So it is perpendicular here. Therefore, this angle will be 90 degrees. OC is the radius to this tangent. Therefore, this will be 90 degrees. Also, this will be 90 degrees. Then we are done with our analysis. Let's quickly dive into the problems. I think we answered almost every question, but let's quickly go have a look on them and see what we can cook there. Let me quickly remove this so that you're not disturbed. So, are you fine with those analysis that we just did now?
Yes, sir.
Are you sure?
Yes, sir.
Okay, thank you. Then now they are saying give the reason why a CAB, CAB is this angle right here? Why this angle here is equal to 25 degrees? What do you think now?
CAB is equal to 25 degrees because the angle between the tangent and the chord is equal to the angle in the alternate segment.
Yes, of tan chord theorem, right?
Yes,
Uh,
sir.
but 100% correct. Tan chord theorem. Okay. Then the next one, give a reason why OCA, this angle here. Why is this angle equal to 25 degrees?
So, sir, since OA
Okay,
and OC
OC are equal.
are radians of a semicircle, that means OA is equals to OC, and we just discovered that OA is 25 degrees.
Yes, then you can say OA is equal to OC, ready.
Yes, sir.
And then now you come to the conclusion that this is equal to 25 because they are angles opposite equal sides. Angles opposite equal sides. Just like that. Then you are done. Now the
Yes.
next question. Prove that CTOB is a cyclic quad. Where is CTOB? CTOB is this one right here. Now, I said to you guys, if you want to prove that part A is a car, you need to know the properties of a car. Then, if you want to prove that part A is a cyclic quad, you need to know the properties of a cyclic quad so that you use those properties to prove that that thing is a cyclic quad. Therefore, now I'm asking you, what do you think we can do to approach this question 9.2?
Okay, sir. So how I would first approach it, I would say ACB.
ACB,
Yes, sir.
which is this
That
one here,
angle.
this 25.
No, ACB. CB.
Oh,
The
oh,
angle
okay,
CB.
this one, ne?
Yes.
Okay,
So I would say that it's a 90-degree angle
okay.
because it's
Let me write what you are saying here. You are saying ACB, then angle there at C is
yes,
equal
sir.
to 90 degrees. Okay?
Yes, sir.
Yes.
Reason being that it's an angle subtended by a diameter, sir.
Oh, okay, your reasoning. Okay, this is 2 marks. Okay.
Okay, then I would say OCK.
O
OCK.
C You mean this one C3? I mean
Yes,
C3
sir.
plus 20, that 25.
Yes, sir. It's also
Okay.
90 degrees.
So you are saying OCK there at C is equal to 90 degrees.
Yes, reason being the radius is perpendicular to the tangent.
And perpendicular to right. Okay. So
Okay.
you are saying this angle here is 90. Okay.
Okay, then I would
Okay.
um okay, I'm just seeing how I can approach this, sorry.
Okay, okay, it's fine. I will just wait for you.
Mm, Okay, so sir, it might take the long way, but then I would then say because we know what OCA is and what
O
ACB
OCA,
is,
right? You are saying OCA. Okay.
because we know that it is 25 degrees, it's given to us, and
Yes.
ACB is 90 degrees. I would say ACB minus OCA, which would give us 65 degrees.
So you are saying this will be 65, right?
Yes, sir.
Okay.
And then um O O O C and
So this is the hint, my hint to you. The opposite angles of a cyclic chord are supplementary.
okay.
Yes, that's my hint to you now. Opposite angles of a cyclic chord are supplementary. So let me ask you.
So then we would have to prove, sorry to interrupt you, sir. So then we would have to prove that CTO and CBO when added together are 180 degrees, sir. So that's why I'm trying to maybe figure out the angles first before
Oh yes. Then also TOB, you can prove that TOB plus TCB
TCB.
is 180 degrees. Then can't you?
Yes, sir.
Yes, you can. Look, what is the size of TCB?
TCB. 90 degrees, sir.
Yes, TCB is 90 degrees. We've said that. And then what is the size of TOB?
It's 90 degrees, sir.
Exactly, this is 90 degrees. So now, when you take TOB and TCB, don't they give us 180 degrees as they are opposite angles in this quadrilateral?
Oh, they do, sir.
Absolutely. So we are going to say TOB is 90 degrees. Why? Because of this perpendicularity here. And then now you can come to the conclusion that when you take this angle plus this angle, they will give us 180 degrees. Therefore, now you can conclude by saying this is a cyclic quadrilateral. Does it now make sense?
Yes, sir.
Okay, thank you. Then 9.3 here is saying write down with reason the size of COB. COB is just this one here. Just this one. Now, what do you think with this one?
Okay. COB.
Yes.
Sir, I would.
What would you do? Oh, this was a nice question paper, eh?
Sir, I wouldn't.
Are you getting there?
So maybe this is a bit of a stretch, but um, oh, so as we see that SCK is a tangent because it was given to us, the angle CB, no, BCK, the 25 degrees,
So which one? BCK.
Yes.
Okay, yes, yes, it's 25.
Yes, sir. So I would say that OBC is also 25 degrees. That
This
O3. O3.
this one.
No, sir.
Which one? O OB
C.
OBC. Is
25
OBC not
degrees.
B1?
No. Be O3, sir. I think it's O3.
So yes, we want. This is what we are looking for, right? This one.
Yes, sir.
So you are saying it's 25.
Oh, no, sir. Hold on.
Oh, okay.
OBC. C. So B1 is equals to 25 degrees because it's it's the same as the 25 degrees, sir.
So you are saying this one is 25.
Yes, sir.
Why?
The angle between the tangent and the chord is equal to the angle in the alternate segment, sir.
Mm, I disagree. I think. Mm, I disagree. Because that theorem, I think it works like this. Okay, let's say this is a tangent. Then now our triangle, all the corners of our triangle hits the circumference of the circle. I don't know if this makes sense.
Yes, sir.
Then
Oh,
now,
okay.
yes, yes, yes. So, but not to waste time, let's do this. This is the angle at the center, and we have that angle at the circumference. I don't know if it makes sense. Does it make sense?
No, not really, sir.
Oh, okay. Let me do this. This is my center, and then I have this. I have this also. This angle is x. What is the size of this angle here?
It's double times the size
Uh, of that one at the circumference, right?
sir.
So what I can do now, let me take this, and then this is still my center now. Okay, I started from this part. From this is theorem 2. Angle at the center is 2 times angle at the circumference. So now let me change the color. Maybe I use the red one. I still have this side goes there. Okay, this one as well goes to the center. Now I take this side, I shift it. Maybe I take this point, I shift this side such that it comes here. Then now I will be left with this portion. Then I shift it again until this line, this green one here, lies on top of this radius. Now it's gonna come here. That's what now we are having. So now still we are having the angle at the center as 2 times angle at the circumference. Does it make sense now?
Yes, sir.
Are you sure?
Um, yes, sir.
Therefore, this angle will be 50 if this is 25. Then you are done. Any
Oh, okay,
question?
sir.
Any
No, sir.
question?
No, sir.
Are you sure?
Yes, sir. I think I
Okay.
just overcomplicated it in my mind, but I understand, sir.
Yeah, yeah, yeah. So the last one, 9.4 here is saying proof, or let me erase this. This one is just saying prove that OK is a tangent. OK is a tangent to the circle that passes through SOC. Then where is SOC? Let's quickly go through our circle SOC. SOC. Okay, this circle is gonna go here. Okay. This is our good round circle here. So we want to prove that okay it's a tangent there. Okay. What do you think with this one? So if this is a tangent, so I'm going to say the angle between this tangent and that chord to the circle should be equal to the angle in the triangle that is opposite the chord. So this is our chord. It needs to be equal to that angle. So we need to show that angle O3 is equal to angle S. Then we will be done by doing that. Then let's see how we can do that. So we said angle O3 is 50, right? We said this
Oh,
is
yes, sir. Yes, sir.
we said this is 50. Now let's see how we can get something there. Okay, okay. What can we do? What can we do? If we have this 90 here, we have, oh, we can do something. Actually, this is nice, hey? Do you have some idea that side? I have something.
Um,
Okay. I think
no,
this is
no,
what,
no, not exactly, sir.
oh, okay, okay. We have this angle here as 25, right?
Yes, sir.
We have 90 here. What is the size of angle T3?
Uh, I'm calculating.
Uh, this side I get 65
65,
for
sir.
this. Okay, yes. Therefore, do you agree if I say this angle here is 65 degrees?
Yes, sir.
Okay. Then if this angle is 65, okay. Now, remember we said this angle here, we said this angle here is 90, right?
Yes, sir.
Reason being radius is perpendicular to the tangent. And
Yes,
again, we said this angle here is 25 degrees, right?
yes, sir.
Therefore, C1 will be 90 minus 25. Do you agree to that?
Yes, sir.
Therefore, C1 will be 65, right?
Yes, sir.
And then that angle S there will be 180 minus 2 times 65.
Yes,
Okay.
sir. Yes, sir.
Then
Yes, sir.
now I get 50 here. I get 50 degrees here. Therefore, now this angle here is equal to that angle. That is the converse of the tan chord theorem that we state your equal angles. Just
Okay,
like
sir.
that. Does it make sense?
Yes, sir.
Are you sure?
Yes, sir.
Now, don't be shy if you don't understand. I can repeat it, but then if you understand, you can move to the next question.
No, I was following, sir. I promise. I understand.
Okay, okay, then I'm glad to hear that, meaning that you're going to nail that paper.
Thank you, sir.
Yes. So I have this other question here, and it's short, hey? It's short.
Okay,
So
so do you mind zooming out a bit so I can see like the whole question?
can you see now?
Thank you. Yes, sir.
Okay. They are saying in the diagram, the circle with the center F is drawn. Okay, points A, B, C, D lies on the circle. Chords A, C, B, D intersect at E. Okay. And then we are given, oh, this is very, very important. EC is equal to ED. EC is meaning EDC is an isosceles triangle. Therefore, this angle will be equal to that angle, right? Then the midpoint of the chord BD. Where is BD? BD. Okay, the midpoint. Oh, K is the midpoint. Meaning if it's the midpoint, KB will be equal to KD. Okay, okay. And then, okay, these are thrown. Let B be X. Then now I go to my favorite technique, DRCPT. Oh, okay. Didn't. Is there a diameter to this circle?
Uh, no, sir.
No. Therefore, we are not going to have maybe that 90 degrees of maybe angles in a semicircle. We are not going to have that. Okay. Is there any radius on this circle?
Yes, sir.
Which one? Oh,
FD and FA.
okay. Let me note that. Now, that implies that FA is equal to FD, right?
Yes, sir.
And that will give us this angle will be equal to this angle.
Yes, sir.
Okay. And then we are done with the radius. Okay. Then C, is there a cyclic quad
That's required. Yes,
on
sir.
which one?
Well, it's ABDC.
BDC, a cyclic
A,
quad.
A,
ABDC. Yes, I agree. This is a cyclic quad. This is a cyclic quad. Therefore, this angle will be equal to this angle, right?
yes, sir.
And again, this angle here, let me use maybe different color. Therefore, this angle will be equal to this angle here. Reason being angles in the same segment. Then we are done with the cyclic quad. Are there any parallel lines?
Uh,
No. Is there any
no,
tangent?
no, no,
No.
sir.
Yes. Yes. Then now let's dive into the questions. Determine with reasons the size of each of the following in terms of x. What is the value of that angle f1?
F1 is equals to X.
Is equal to x.
2X.
Oh, I was shocked. 2x. This is a mark. Okay. And then,
Do I give a reason, sir?
oh, if you don't give a reason, I give you 1 mark out of 2 marks.
Okay. Angle at the center is 2 times bigger than the angle at the circumference, sir.
Then now as a mark, I give you 2 marks if you state the reasoning.
Yes, sir.
Yes. Now determine the size of angle C in terms of x.
Angle C is equals to X. Reason
Okay.
being, angles subtended by the same arc are equal or
Angle.
semicircle.
Okay. In the same segment. In the same segment. In the same segment. Then I give you 2 marks for the statement and the reason.
Yes, sir.
You already have 4 marks. I mean, that's a good 4 marks out of whatever paper it will be. You already have 4 marks. Wow, this is nice. Then now let's come to disproving. Prove with reasons that A, F, E, D, E, D. Or let me maybe do this. Prove that A, F, E, D, A, F, E, D is a cyclic quad. Then you need to know the properties of a cyclic quad. This is A, F, E, D, A, F. This is it, A, F, E, D. We need to prove that this is a cyclic quad. So, how do you think we are now going to do with this one, eh?
Okay.
Hey, this question is nice, man. I love this question. I thought it was challenging, but okay, let me give you a chance maybe to try this question and then you will tell me if maybe it's challenging somehow so that I can explain.
E.
Is there anything that is coming along?
Yes, sir. There's something that's coming along.
Oh,
Um,
yes. You can share that thing.
okay, sir. So angle, we know that angle E1,
Angle E1, okay.
that is just outside the
Yeah,
quadrilateral,
we are
is
saying this one.
it's two times bigger than angle X.
This angle here, you are saying is two times. Reason being, maybe
Uh, could we say that angles in the same segment?
angles. So you want to say this angle is 2x,
Yes, sir.
and you are saying is equal to this one.
Yes, sir.
Oh, almost, but no, incorrect. But I thought you saw something, but oh, but yeah, you were almost there. But
Okay.
no, these are not angles in the same segment because remember I
No,
said,
sir. I was gonna prove it by saying they're subtended by the same chord. I was saying E1 is 2x and F1 is 2x, and then I was going to say these angles are subtended by the same chord. Then that
so
would
okay, okay, let's say this is our circle here, a beautiful circle, eh?
yes, sir.
So you telling me that this angle is equal to this angle.
Yes, sir.
So you are telling me that if I have this cyclic quad like this, let me try to draw. Okay, this is F, this is E, and then there's line that is produced there. You are saying this angle is equal to this angle.
Yes, sir.
Uh,
Ooh,
what?
no. No, 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 no,
You
no.
see your mistake, ne?
Yes, sir.
Because yeah, I'm glad because that reasoning of exterior angle is saying this angle that is outside here is equal to that one. When you get in is going to be the opposite one, will be equal to that one. So this is what you should have done. You use that information that you're given. So uh, let me maybe do this. I'm going to ask you questions now. We said this angle is 2x, right?
Yes, sir.
Okay. Now I'm asking you this. What is this? What is the size of this angle?
2x, sir.
2x.
No, no.
Remember, we answered this, and you are the one, in fact, who answered this, and you didn't say to me it's 2x. What is this angle here?
Oh, x. Oh,
Reason
okay.
being,
Uh, angles in the same segment.
aha, fine, I agree. What is the size of this angle here?
It's x as well, sir, because ED and EC are equal and it's given.
Okay, I agree. Now, again, I'm going to ask you this. Uh, okay, what is the size of this angle here?
Hmm.
This is
Plus
what this is what I emphasized in the properties of the quadrilaterals with our first lessons. This angle in a triangle is equal to this angle plus that angle, right?
yes, sir.
When you add this and that, it gives us the exterior angle. Therefore, if this is x and this is x, this will be 2x. X plus x is 2x.
Yes, sir.
So this angle is 2x. Does it make sense?
Yes, sir.
Therefore, now we have that bow tie shape. This one right here, this one. Then now this angle, because we found that this is 2x, that is 2x. Now we can conclude that this is a cyclic quad. Then now we use the converse of angles in the same segment or angles subtended by the same arc.
Oh,
Then we are done.
yes. Oh, yes, sir.
Does it make sense?
Oh, yes, sir. I
Are
don't
you
know how
sure?
I didn't see that, sir.
Are you sure it makes sense?
Yes, sir.
Okay, you just need to okay. Firstly, when you do those analysis using DRCPT, maybe on the paper, just write maybe in a neat way that they won't do any mess of disturbance. It will help you a lot. Then note this kind of information that this is equal to that, whatever, whatever. It will help you a lot.
Okay, thank you, sir.
Yes, it's a pleasure, ma'am. And then now the last question which of this part, prove that, oh man, it's a long question, 6 marks. Prove that f3 is equal to x. Where is f3? There is f3 right there. What can we do? Let me maybe do this. We set this angle here. Excuse me. We said this is x. This is x. This is 2x. This is 2x. So we want to get f3. F3. So let's maybe think on how we can do this. Okay. Okay. This one can be 2x as well. But what can we do here? I think they can't give us this information just to be there. We must use maybe this information that this is the midpoint for that. Okay, this is 90. Do you agree if I say this is 90 degrees? Do you agree?
Yes, sir.
What's the
Because
what's the
line
reason?
from center to midpoint of a chord is perpendicular to the chord.
Absolutely correct. Yes, 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 yes. Then now let's see what we can do. Okay, okay, okay. We have that 90. We have this 2x here. What can we do? Okay, we can get this angle here. Wait, can't we get this angle here? We can, and we can get that one. But how can we use that information? Think. Boom, boom, boom. Okay. Let me say 180 degrees minus 2x. Then, okay, I get this. I divide this by 2. I get 90 minus x. For this part, this is 90 minus x. And this one here will too be 90 minus x. Okay, then let's see. Then that implies that this whole angle here, okay, this is 90, this is x, this angle here, is it 90? Oh, okay, no, it's not. But what can we do? This here is 180 minus 2x, 180 minus x, oh, minus 2x, not just x. Okay, and then what else? That one up there is 2x, this one. And then, oh, okay, remember we proved that AFED is a cyclic quad, right?
Yes, sir.
Therefore, this angle here, this one, will be equal to this angle, right?
Yes, sir.
Can you see that?
Yes, sir.
Therefore, this angle will be 90 minus x. Then now, to this triangle, how can we find f3? F3 is 180 minus this 90 minus this 90 minus x. So 180 degrees minus that's 90 there minus this 90 minus x. Okay, and then we are going to have this 90 here decrease minus that 90 there plus x. This cancel out, therefore our f3 is equal to x. Does it make sense? You are done. You are done just like that. Does it make sense? Didn't say?
No, sir, you were going a bit fast, but I was following. But maybe I just need to process it. You did explain it well, sir, though.
Oh, all right. No, it's fine. Let me re-explain. This is what I said. Let me do this, do this, do this. So I think the other advice that I can say to you is that with every information that you are given, try by all means to use it and then highlight everything that you can do that you know that is mathematically correct on your diagram. So what we know that we got from this information, firstly, we got that this angle here is 2x, right? We got that this is x, and we found that this one as well is 2x, right?
Yes, sir.
And then now what we can say is that this is 90 degrees. Angle FKE is 90 degrees. Then you state your reasoning that you have said. That's 2 marks. Okay? And then afterwards, now using this technique DRCPT, when we were here, we agreed that FA and FD is a cyclic is an isosceles triangle because AF and FD is a radii. Therefore, this is an isosceles triangle. That it implies that this angle will be equal to that angle. Does that make sense?
Yes, sir.
Yes. Now, how can we find these other two angles here? You can let these angles maybe be k, whatever value it is. Okay, let's say k. Let's say k here, right? And then you are going to solve for value k. What you are going to do, you're having that k plus k plus 2x is equal to 180 degrees, right? And then you're going to have 2k is equal to 180 degrees minus 2x. Therefore, k is equal to 180 degrees minus 2x over 2. And therefore, it will give us 90 degrees minus x. Therefore, this part here now is no longer k, but is 90 minus x. This part here is 90 minus x. This one as well will be 90 minus x. Does this make sense?
Yes, sir.
Okay, fine. Now we come to this cyclic quad here. We said this is a cyclic quad. This is a cyclic quad. Then there is a line right there. So if we've got a cyclic quad like this, and then you have that line, then this angle will be equal to that angle. Exterior angle of a cyclic quad is equal to interior opposite angle. Does this make sense?
Yes, sir.
Therefore, do you agree if I say now this angle is equal to that angle?
Yes, sir. Yes, sir.
Okay, yes, this angle will be 90 minus x. Yes. Now we have that 90 here, we have 90 minus x. We want f3. We use the interior angles of a triangle, which is 180 minus this 90 minus x minus that 90 then you're going to be left with your F3, which is x.
Yes, sir. Yes, sir.
Are you sure now it makes sense?
Yes, sir.
Sure.
Thank you, sir. Yes, sir. Thank you, sir.
Okay, cool. Then now let's have a look maybe on this one. Oh, question 8. They are saying in the tangent, the diagram, O is the center of the circle, and radii. Oh, this is an important information. Radii, OH, and OJ are thrown. Oh, this is equal to that. This implies that OJH is an isosceles triangle. Do you agree if I say H3 is equal to J1?
Yes, sir.
Okay, that's fine. And then now I'm going to say, I continue with the statement that tangent whatever, whatever, blah, blah, is thrown to triangle. Then there is the parallel lines. Oh, now I go to my very powerful technique, Dr. Cape Town. Dr. Cape Town. D. Is there a diameter there in the diagram?
No, sir.
Okay, then we can skip our D or just scratch it out. Is there a radius?
Yes, sir.
Oh, yes, and we already noted that, and then we used that information that if this one is equal to that one, these angles will be equal, right?
Yes, sir.
Okay, fine. And then now, what are we going to do? We are going to continue with our DRCPT. Is there a cyclic quad?
No, sir.
No. Okay. Are there parallel lines?
Wait, sir. Yes. No, 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 sir. No, sir.
Oh, okay. Are there parallel lines?
No, sir.
Oh, you're saying no or yes?
There are no parallel lines, but I think there is a cyclic quad, sir.
Look at this.
Oh, oh. Yes, parallel lines,
Okay,
sir.
okay. You were saying you think there is a cyclic quad. Which one, maybe?
So wouldn't you say HGJO is a cyclic quad?
Sorry?
HGJO.
GJOH.
Yes.
Oh, no, it's not. Because
Okay,
remember,
okay.
a cyclic quad we said is a quadrilateral whereby each four corners touches the circumference.
Oh, yes, sir.
So this is the cyclic quad, the green one here, and then sorry, let me do this. And then again, this this is a cyclic quad. Why? Because those four corners are on the circumference. This is a corner, this is a corner, this is a corner, this is a corner. Does it make sense?
Yes, sir.
Okay. Now we have those parallel lines. We have those parallel lines. We can use our technique. Maths is fun. Can use our technique. Maths is fun because there exist these parallel lines. So for F, if these lines are parallel, this angle is equal to that angle, corresponding angles, then you state your parallel lines. But we cannot have it because this line maybe is not protruded to that, so that you can have this angle and this angle. So we can't use F, but we can use co-interior angles because we have something like U. Here is my U. Can you see that?
Yes, sir.
Therefore, this angle here plus that angle gives me 180 degrees co-interior angles because GJ is parallel to KH. Then we are done with this one. Then our N, this must be equal to that only if this is parallel to that one. Therefore, my Z is here. This is equal to that. If this is X, that will be X. Alternate angles, then I state my parallel lines. So we are done with parallel lines. Is there tangent to the circle?
Yes, sir.
Oh, yes. Then if there is a tangent, you can use a tan chord theorem. If there is a tangent, you can use a tan chord theorem. In this case, this angle will be equal to that angle, right?
Yes, sir.
You can also use that theorem that a tangent is perpendicular to the radius. Is 90 degrees here, right?
Yes, sir.
Oh, fine. Then now let's dive into the questions using those analyses that we did. Name giving reasons 3 angles that are equal to x. Which one do you think is equal to x here?
J1 is equal to x.
J1.
Yes, sir.
Okay, you are saying, I don't know why, but I will hear from you. Okay, why?
Angles opposite equal radii in triangle OJH, sir.
Why? I'm just curious about where did you get this x?
So if angle O is 2x, then that means on angle G is x, right?
Oh, angle G, ne?
Yes, sir.
Oh, yes, angle G, I agree. Angle G is equal to x. Reason being,
Angles in angles at the center angle at the center is 2 times bigger than angle at the circumference.
okay, that is 2 marks. Okay, okay. And then the other one?
Angle H1 is x because angle between tangent and chord is equal to the angle in the alternate segment. Tan
Oh,
chord
no.
theorem.
Oh, no. This is not tan chord. This is that Z that we talked about with parallel lines. The
Oh,
alternate.
okay. So then alternate
Yes.
angles are equal.
Yes. And then now, when you apply that tan chord theorem, is this angle between the tangent and the chord will be equal to the angle that is opposite the chord. Therefore, this angle will be x as well. Does it make sense?
Yes, sir.
Oh, cool. Then you are done with your 5 marks. Good, 5 marks. Easy marks, eh? Yeah. So now, prove that H2 is equal to H3. So we are here now. Hey, now,
H,
yeah,
sir.
we want to prove that H3 is equal to H2.
So,
I mean,
sir, I would say
H2.
H2 is equals to J2.
You would say H2 is equal to J2.
Yes, saying
Oh,
angles in the same segment.
oh no, because is there any shape that forms that bow tie that I love?
No.
Oh yes, therefore you cannot say angles in the same segment if you can't
Oh,
see that shape of a bow tie. Does it make sense?
yes, sir.
Therefore, don't forget the analysis that we did using DRCPT. Just keep them in mind. We said this is 90 degrees. Do you remember why?
Yes, sir.
Why?
OH is 90.
Yes, why?
Is the radius, sir.
Yes, and then it's perpendicular to the tangent.
Yes.
Therefore, what will the size of this be of this part?
90 minus x, sir.
Yes. So that is H2, right?
Yes, sir.
Yes. Now let's do this. Let's do this. Let's do this. Uh, can we find the size of this angle? Can we? We can, because we have that angle, we have that angle. We can use the sum of all interior angles of a triangle to find
Oh,
that.
yes, sir. Yes, sir.
Therefore, that angle will be equal to 180 degrees minus 2x, right?
Yes, sir.
The whole of that angle will be that. Now, because we have the whole of that angle and this portion, can't we get this portion here? We can. Saying this whole angle 180 degrees minus 2x minus that 90 minus x will give me 90 plus x. Therefore, this here will give me 180 minus 90 is 90 degrees. X minus 2x is minus x. Therefore, also for this portion, I get 90 minus x. Therefore, this angle is equal to that angle. We have proved that.
Oh,
Does it make sense?
yes, sir.
Are you sure?
So, yes, sir. So,
Okay. Any question?
no, sir.
Oh, okay. And let's end here for this part. For this part of grade 11 Euclidean geometry. I know maybe it's time up. Do you mind if I can quickly maybe touch up with the grade 12 Euclidean geometry?
No, I don't mind at all, sir.
Oh, okay, fine. Thank you, thank you. But please, whenever you go to the question paper with this paper two thing, when you get there to this grade 11 part, just go with this technique, DRCPT, and then do your analysis and then dive into the questions. Whatever you noted using this technique, just never forget that because you will need it somewhere in the questions there.
Okay, sir. Thank you,
Eh,
sir.
It will help you a lot. So let's say we're having this. Now we are going to play around proportionality theorem. They are saying in the figure below PQRS is a parallelogram. So do you still remember the properties of a palm?
Oh, properties of a palm. I
Oh,
think so, sir.
you forgot maybe. But properties of a palm is that the opposite sides of a palm are parallel, right?
Yes, sir.
Then also this one will be parallel to this one. That's what we know. And opposite sides of a palm are equal. Okay, are equal. And they are equal in length and opposite angles of a palm, but I don't think we're gonna need lengths because I mean angles because now we're working with lengths of the sides. So let's okay, then also this information, this is parallel to that. Okay, then we are given QB. Where is Q? QB. We are given QB as 2. We are given BR as 5. So after you did this, so introduced variables to your ratios 2A, 5A. Does this make sense?
Yes, sir.
If you give this part A, also give this part A. You can't say this is 2A and this is 5B. Just give the whole side the same variable. Now determine the PQ over OC. Where is PQ? This is PQ. PQ over OC. Uh, do you have an idea of what we can do here?
No, not really, sir.
Okay. Can you see this triangle here? In
Yes,
this
sir.
triangle, let's say I'm having Q, B, R, D, D, and S. Will you agree if I say to you QB over BR is equal to, SD over DR, reason being Propp theorem.
Sir.
Propp theorem, then I state my parallel lines. Do you agree?
Yes, sir.
Exactly. That's what we are going to do because now we can apply the proportionality theorem in this part. Look at this. This is our triangle here. Can you see that?
Yes, sir.
And this line is parallel to that line. Therefore, the ratio for this will be equal to the ratio of that other one. But because you already introduced A to this side, let this ratio for this one now be B, right?
Yes, sir.
Yes. Now, what can we do
So
to move?
maybe
Sorry?
we could say QB. No, QB is over BR.
QB, where is QB? Okay, this is QB. Oh, you're saying QB over BR?
Yes, sir.
Yes,
Because
QB.
QS is parallel to BC.
Yes, on the paper, this is what you are going to write. QB over BR is equal to SD over DR. Then proportionality theorem, then you state your parallel lines. QS is parallel to BC. Then
Yes.
they will be both be equal to 2 over 5. Okay. Then now, because okay, these are marks. You are not going to erase it. I'm just erasing it because of my space, ne?
Yes, sir.
Yes, fine. Now what can we do again? Okay. Uh what is the whole of this size, this side here is 2 is 5, I mean it's 2 plus 5 is 7b. And then okay, fine, hold it like that. Where is this OC now? This is OC. This is nice. Now this is real maths. Let's come to this triangle. Oh, I wish I was a teacher for grade 12, eh? uh so this triangle, this one. Now I'm going to ask you a question. Be ready for this. Be ready for this. Be ready for this. Do you agree now if I say QB over BR is equal to OC over CR? They are both equal to 2 over 5.
Yes.
Prop theorem. Same parallel lines. Do you agree?
Yes, sir.
Okay, thank you. Then now, let's give this a variable. Let's say 2C over 5C right here. Okay, so now we have some taste of what we are going to do now. Let's do this. Then we want PQ. That's what we are required to find. PQ over OC. PQ over OC. Then what is PQ? PQ is the same as, do you agree now if I say, or in fact, because we're going to give some reasoning. On the other side, maybe you can say PQ is equal to SR. Opposite sides of a palm are equal. Does it make sense?
Yes, sir.
So PQ is equal to SR over OC. Okay. Yes. And then now what can we do? SR is 7B. It's 7B all over. OC is 2C. Is 2C. Now when we are here, we need to find the relationship between C and B so that we can cook something. What do you now think we can do? Is there anything that comes to your mind, maybe?
Also,
Let me think. Yeah, this is a little bit challenging, but let's see. Okay, oh, see, it's this part here. What can we cook here? Uh, this is OC. And it's a diagonal a of this palm. Okay, the whole of this size will be 7C. Okay. And then now, we're almost there though. Mm, uh, set this is equal to that, okay. And this as well is equal to that. I agree. Therefore, this part again here will be 7c this side. Okay. Then what else can we do? Bit challenging. And can we just please skip this question? I will try to work it out when I get time and drop it on the inbox there.
Yes, sir.
Oh, thank you. Then we will just have a look on it there. This is the grade 11 part. We did this. This is the grade 11 part. Where is the grade 12 part? Okay, it's not here. Why is it not here? Oh, I can't see it here, but so do you understand these ratio things, how they work though?
Half and half, sir, but with a little bit more practice by Friday, I should be well inclined in that topic, sir.
Oh, okay, man. I believe in you there. Good luck. I will just try to work out on that problem and I will just drop it on inbox. We can just end here for today. I will see you again tonight on that class.
Yes, sir. It was
Cheers.
good, sir. Thank you, sir, for the lesson.
Oh, sharp, 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 sharp. It's a pleasure.
Thank you. Bye-bye, sir.
Sharp, bye. Good luck there on Friday.
Thank you, sir. Thank you, sir.
Sharp.
I'll make you proud, sir.
Oh,
Bye-bye.
man, I would love